Hello and welcome to this SlimDevOps Live episode 19. I am delighted that I'm joined by my colleague Ayse for this stream. If you are watching this on YouTube, this was originally recorded on twitch.tv/SlimDevOps on October the 13th. If you would like to join in these streams interactively, then head over to our Twitch channel and give us a follow. Hello, Ayse. How are you?
Long time no see.
We're gonna keep that pretense up for the benefit of those people that are just joining us, I think. So we've just done a version of this, a very short, light-hearted version of this on our virtual booth at KubeCon. But boy, howdy, have you got some exciting information to share. This is gonna be great. If you're interested in containers, or a data nerd, or a Linux nerd, or basically an open source developer, this is a goldmine of useful information and many surprising twists and turns along the way. So I'm not going to bury the lead too much. Ayse, what is the topic that we are going to be discussing today?
So we have just released a new report. It's titled Slim.AI Top Public Containers Report 2021. And we looked at 130 containers, graded them into 9 different categories to better understand if there are any in-group, out-group dynamics within them. And within these categories, we selected more general purpose ones, such as data science, programming languages, web development. And there are those that are more special purpose, like DevOps or infrastructure or build tools. And we basically wanted to understand what's going on under the hood. And we found some really surprising things. We also found some other things that we hypothesized that would be true. And we were able to quantify and visualize it beautifully at the end.
So, before we get into this, I think it's worth asking the question, how on earth do you tackle the problem of analysing it was more than 100 actually. It was, how many containers did you actually have in this initial data pool?
The sample size is 130 containers.
Okay,
but so a lot more to it than 100. And like we can talk about the curation process, how we selected these in more detail in a bit. But we wanted to look into those containers that are in common use, Martin. So we looked at the star count, the pool volume, the official Docker image status as a proxy for popularity. But we also looked into the usage of our own platform, our early access Slim.AI platform. What are the top containers that are being scanned there? And we also looked at, we talked to our container enthusiasts, container experts in-house, so that there's some qualitative curation to the selection process too.
So given the challenge of taking this on, I think the first time anyone's conducted any kind of analysis of this nature and scale into the container ecosystem, where do you start? How did you like figure out where to begin with all of this?
The first thing that you would do is, as a data scientist, I looked at all the past studies to, if somebody has already done it, right, and found out what is under the hood with these containers, what's going on, right? It could have been much easier if someone else have done it for us, but we couldn't find anything, so we had to do it all by ourselves. And that curation process that I talked about, finding out those containers, and maybe we start showing some beautiful visuals from our report to Martin at
Sure.
this stage. And we can go to the very end of that report, and even in the cover you see that circular dendrogram of what these containers are. So if you go to the very end, figure 9, which is, I believe that, this graph here. So it might be very hard to read here, but if you download the PDF copy of this, you can see which categories are selected, those 9 categories, as I said, some generic ones and more spatial purpose ones, programming languages, DevOps, infrastructure, and you can see which specific containers that we have selected for this study.
Right.
And it is, as I said, starting with top containers is, some of these containers, if you look into their Docker Hub pull counts, Martin, they've been pulled 500 million times, 1 billion plus times. This is probably a fair view of like most modern software development starting process. Most people are using one or multiple of these containers for their application developing process right now. So I do think that it is a although it's a small sample set compared to the 8 million Docker Hub images out there, it is very representative of everything that's being in use today.
Yeah, but I think that's fair, right? Nobody's undertaken an initiative like this before. You have to start somewhere. 100 is a nice human manageable in-brain number to start with. I know you slightly extended that to approximately 130 or so. But you have to start somewhere, and I think partway through this conversation you're going to start to talk about like where do we go next with this kind of analysis and research, which is fascinating. And the reason I've just moved back to this view is you can see above my head Slim.AI. If you would like to follow along with us, you can go to our articles and you can sign up and get a full copy of the report, or you can join our Discord community, which there's also links for in the footer of the website above. And our colleague Peter has already posted a full copy of the report in our Discord channel. So if you want to follow along as Ayse explains all of the ins and outs of the methodology and the discoveries, then you can access the full document as well. So it's even 100 containers is fairly comprehensive. I know you talked about like it's not just volume, it's not just a popularity contest, right?
Exactly. It is like popularity is part of this, and with a lot of people who are starting out with containers, I'm pretty sure these containers are starting points. But even for experts, from our conversations with other people who are more advanced in their knowledge of containers, these starting points seems to be pretty common. So it made sense to look into the top containers and understanding what's going on at that tip, that top 1%, if you will. And again, because of the pool counts, the popularity of these, I feel like the findings are very significant in terms of the what's going on really with these containers. But we look forward to expand the data set. We actually started with even like our MVP was much smaller than this, and then we slowly started expanding the set. And at this point we said this is a good enough sample size, lots of pools with these containers, a lot of popular images. We could have gone in depth. We can say like, let's get one of these containers and see what happened historically with all these different tags of this image. But that's the next step. And then expanding the sample size is another step. I would love to look into, as a person who is in love with data, I would love to look at everything on Docker Hub and beyond, all these other registries. But this, especially at this stage, was like we came to a threshold where we were finding really interesting things, and we wanted to publish it as a baseline as we start trending what's going on in these containers.
And you've touched on a couple of interesting points there. So first of all is Docker Hub. There's some significant uptake in Docker Hub pulls over the last year.
Exactly. So to quantify that a little bit, right? Docker Hub goes back to 2014. So between 2014 to 2020, those 6 years, the all-time pulls were 130 billion.
Billion. Just so everyone heard that, that's billion. not
Yes,
million,
not
130 billion.
billion, billion, huge, almost like this. If you look at all these growth graphs, the number of pools and stars and whatnot at Docker Hub, it's a hockey stick. It's a huge growth curve. But then in the last 12 months, 2020 to 2021, that number, the all-time pools, almost tripled, 300 to 318 billion. So from 130 billion to 318 billion, I believe. So it is, there's a proliferation of containers and lots of use. And the containers that we selected, as I mentioned, some of them are being pulled more than 1 billion times or
Right.
500 million plus times.
So,
Yeah.
therefore, a significant impact on the modern software development, delivery, and deployment, landscape, if you're looking at things that are being deployed at that kind of scale. Because even web scale, that is a significant proportion of like the active running infrastructure on the internet. So, Docker Hub is not the only registry, though.
Exactly. In fact, I think it is. It's said that about half of Word's containers live in Docker Hub. The rest is elsewhere.
Right.
All these registries. So it is an aim of us to look into these other registries. But again, starting here with these top containers is a quite meaningful start. And I have a feeling that with the law of large numbers, all these other things, I feel like the rest, especially in Docker Hub, for example, we will start seeing a long tail where a lot of the findings that we see here will be applicable to most of the long tail containers too.
Right. So that outlines like your initial picks. Was there anything else that sort of influenced your initial sort of selection criteria?
Maybe we can talk, before talking about the findings, which I can't wait. Honestly, that's the most fun part. But I also value all these methodology, structure, questions, and conversations because, honestly, if the data is crappy, if the sample size is not applicable, right, it is not your study is not valid. But I feel very confident about the numbers that we have here, plus the methodology. Right, the process. We try to model a real-world, scenario where a developer finds this public container for their project, and they're part of this CI/CD pipeline. So we mocked a CI/CD pipeline flow where we would pull a container like a developer and then scan it using standard tools like our X-ray feature from our Docker Slim tool, or the software bill of materials from Swift, or vulnerabilities from Gripe. So we looked at all of these for all these different containers that we are looking at. And we pulled the latest versions reports for all of them. And then we started looking into things like scan time. We measured how much it took to scan an image, and then we analyzed the contents of all of these tools reports to understand what's going on under the hood.
Okay, so when we talk about scanning a container image, what does scanning actually mean? What is it you're interrogating and trying to uncover?
Yeah, we will look into some of the graphs, again, beautiful images that we created, but we would like to understand the size of these containers. We would like to understand how many files there are in these containers. Are there packages? Are there licenses, unique libraries, spatial permissions? So, and how are these things structured? So everything that's in there, plus the vulnerabilities that they might contain. And it's not just the sheer count of vulnerabilities, but the severity of these vulnerabilities.
Mm-hmm.
Are they critical and high? Coming from cybersecurity industry, it's really important to me. The sheer count is important, but I would like to understand what is the percent of critical incidents that needs to be solved. What is the percent of unknown vulnerabilities? As in, there are certain things that we haven't even gone into investigation. We know that it's a vulnerability, but we don't know much enough to label it for a severity category, which I think is even scarier than a critical incident, right? Then understanding if there's a fix for that vulnerability. So we can see if there's a fix or a no fix for that vulnerability. So looking into all these different things through scanning so that it is safe to ship a container into a production environment and continuously use it in your CI/CD workflow.
And there's quite the conversation to be had there, because you and I have a shared background in information security. I in a past life was a vulnerability analyst and an information security officer. So, these were things that I was taking very seriously in terms of, the deployments and how we operated our infrastructure at a significant scale. And this was over 10 years ago. But, that industry that I worked in at the time was kind of at the forefront of, driving that kind of awareness and thought. But also, I've lost the thread. Bother. Well, can I find it? My brain. No, I can't find it. Never mind. I'm sure it will crop up again. Oh no, actually I can find it. There's kind of an interesting there's a very spectacular difference in the container images that are published by the Linux vendors versus those people publishing their platforms and ecosystems and APIs. And when we get to that point, because of the time that I spent at Canonical, I can offer some insight into why things look so different in the graphs and the exposure that you're going to show. That those right-sized risk management principles look very different, and we'll get into that.
I can't wait to hear people like yourself, like anyone who spent some time in this container world. I would like to hear what their insight is, what they see when they look at these graphs, right? Because coming from a data science, cybersecurity background, I spent quite some time in the container world right now. Now that I'm almost in my first first year at Slim.AI, and in a little bit before that, but we might not be understanding what's going on under every category, and someone who has spent a lot of time with the data science containers can compare them to programming language containers, for example, because all of these charts are showing these categorical comparisons, and people who have spent more time in these different categories can actually give us more insight into what's going on.
So is there anything else you'd like to outline about the sort of the setup to this analysis process before we start to dig into the findings and the results?
I think it's important to maybe just be very specific about the purpose here, Martin. So what was our purpose when we were creating this report, right? At Slim.AI, we are a startup that's focused on container best practices. And we are very concerned about developer experience, and we want to improve developer experience. And we have a team of people who are container enthusiasts. So we basically wanted to find out what's inside these public images that serve as the starting point for many modern software development projects. And we were asking questions like are these containers easy to use? Are they efficient? Are they safe, secure? Will they cause any issues when you ship your containers to production? So it is for us we wanted to understand what's going on under the hood for a reason, because we work with these all the time. But again, it could be the case that certain people in our own teams focused on certain categories, and some other categories are still the areas that we haven't explored yet. So I would love to hear from our audience, from readers down the road, to come up with feedback and for their insights, looking at these pretty images that we put out there.
Indeed. And as we dig into this, if you've got questions, please put them into the chat on Twitch. I will pull those out and we'll try and field those as best we can as we go through this. And also, I'd like to welcome back, our community and our friends who are here. Thank you for the compliments on my fine wearing of the Slim.AI cap. I know that those of you that recently received community swag from Slim.AI didn't get a fine cap like this, but I did.
I should have worn mine. Yeah, totally. How did I forget that?
I've got my socks on and everything. I'm like fully regaled in the Slim.AI. It's far too warm for socks, but I'm wearing them anyway. I'm totally committed.
Well done,
Right then. So shall we dig into the graphs and the numbers? And if people have got questions, I'll be paying close attention. And I can see a number of our community are already starting to speculate on some of the outcomes from this. So this will be interesting.
Yes. So maybe we start with the first finding. Maybe we start with page 7. There's a graph there that talks about size versus scan time. Brilliant. Yeah, let's start there because it's a good one to begin with. So our first finding is about how bloated large containers can be a time sink in that in your CI/CD workflow, right? What we see here is almost a perfect correlation between container size and scan time. And after the fact, it's just like it's obvious. I wasn't. We had this hypothesis that this could be the case, but I was also thinking that there could be a lot more going on behind the scenes. It could be a function of complexity, right? It could be the number of packages, permissions, licenses in there. But that seems like, especially at the smaller size piece of this graph, we are seeing a linear relationship. Like for every 500 megabits, we add another 50 seconds of scan time. And then as you grow your images in this set larger, the scan time starts growing with accelerated rates, which might not be the best news, right? It could indicate that there's an S-curve or an exponential relationship. Like the complexity rises as the size of these containers go big. And these few seconds might seem trivial, right? If you are just working with a couple containers and shipping them to production. But in typical environments right now, and we shared some insights here, reference a couple different reports, right? If you're working with thousands of images, there was this survey that said 60% of all companies that they surveyed are using more than 250 container images. A lot of firms are hitting thousands right now. And if your engineering team is shipping images at faster release and deployment times, like multiple times a day, then this can mean that there is a huge productivity loss for your organization. Okay.
Right.
You were going to say something?
Well, I was just looking, so I can see our podcast, who's one of our community members and also a fellow data scientist, who is a big fan of R. And I think that most of the analysis that you pulled together using R. Is that right, Ayse?
Yes, for visualizations mostly, but we use Python. We used a couple data mining tools, but R has a big place in my heart,
But I think our podcast is already sort of intuiting the future of where we're going with this presentation and some of the things that we're going to reveal. But it's not as clear cut as you might think as we dig into this analysis. What I find interesting about this is this scan time metric. This is something that you do if you care about the quality of the infrastructure and the applications that make up your infrastructure that you're deploying into your production environment, particularly if you're like in the financial services industry and you've got, or even the pharmaceutical industry, which is one of my backgrounds, and I know shared by some of our community members. You have compliance and regulation that you need to adhere to. And therefore, the size of your container, which some people see as a vanity metric, I made my container smaller. They see this as, a vanity improvement. There is actually an operational benefit to moving optimized containers around your infrastructure.
Exactly. Scan time is very positively correlated with other things like the number of packages, the license, the complexity, as I said. So it is not only a function of size, but you see these things being tightly coupled. So as size increases, you see that there's some complexity challenges. But even with the smaller images, we have seen some not so innocent issues. So it is not just about how big your container is. And in certain environments, for example, we looked at data science category specifically, very large containers on average. Maybe for that, we can look into figure number 2. Which shows that categories versus size on page 11.
On
Martin?
page 11. Okay, sure thing. One moment. I've just seen a question that we also need to accommodate. Is it this chart here that you want to display?
Yeah, because I wanted to showcase how there are some in-group, out-group dynamics, right? In data science programming languages, web development, those general purpose ones seems to have the largest containers. And as expected, local development, base OS, the DevOps, a lot of the infrastructure guys, the build tools seem to be smaller. But when we look into the actual contents of these things and the vulnerabilities and the severity of those vulnerabilities, and if there's a fix for those vulnerabilities, all those different insights, it's not necessarily the data science containers that are the most vulnerable, right, always, because there is a community potentially who are very intentional about looking into these things. But we will talk about it, but I wanted to make that point around, yes, that we are seeing the scan time and size correlation, but we are looking into a bigger picture here to understand, right, the complexity here.
So I'm chuckling because I'm seeing comments and questions coming in. So for the purposes of clarity, Big Pod asks, what type of scan does this data talk about?
We used common tools, like as I said, X-ray tool, a Docker Slim feature that we have. All of them are open source scanning tools. We used our X-ray tool. We used Gripe for vulnerabilities, the number of vulnerabilities, the severity level. So number of matches, what is the severity level, what is the vulnerability ID, and then we looked into SIFT for software bill of materials to understand how many unique libraries, licenses, spatial permissions, packages are there in these containers.
Right.
Very fairly typical scanning.
Yeah, because as an individual, I don't care about that stuff, right? I just want to make some software and I want to make it work. And I don't care necessarily about what the mixed license implications might be, because it's something I'm, shoving on a Raspberry Pi or, a container that I'm just running for experimental purposes. But if you're a large organization delivering your platform at web scale, you need to have some accountability over, the licenses and the compatibility of those licenses that are in use. And also, what's your exposure do you know whether or not a particular version of a particular library is used in your infrastructure? And if so, where is it used? What's your exposure, if at all? If you're exposed, how much, how often, and where? So the purpose of these scan tools is to assess those different risk factors that feed into your security, information security policies, and mitigations and right sizing processes.
Exactly, which is actually a great segue into looking into the finding two on page 10, which looks into the complexity here, but the findings of those scans. So what we're seeing here, and maybe let's focus on the packages. This is
Okay.
focusing on licenses and special permit. Yep, the yellow one. Brilliant. So this is a simple box plot visual where we are seeing different categories, number of packages on your y-axis, the lower and upper quartile, the median, as well as the outliers, the smallest and the largest ones in the sample set in each category, right? So what our analysis shows is that understanding the composure of the images in every category, both general and spatial purpose, requires massive effort. I'm not the best container expert in our team, but looking at these numbers from a data science perspective, like look at the distributions here, Martin, right? Even the averages seems to be surprisingly high in packages,
Mm-hmm.
right? The median numbers. It's typical to see hundreds of packages, even in small spatial purpose containers. And as we start exploring the larger images in more generic containers like data science and programming languages, especially at the outliers, we're talking about 12, 1300 packages, right? 20, 25 special permissions, 70 plus licenses. So if you start with these containers, which they are pretty developer friendly, we should maybe mention this as well. All these packages, package libraries, helper libraries, they are assets that make everything more fun and this initial experimentation easier for the developers. But you need to start thinking about what it means down the funnel.
Yeah, so there's a couple of things that really leapt out at me when I saw this presentation for the first time. The first is local development. It's interesting that it's tagged or labeled local development because these are containers that are in the 100 most popular containers in production. And yet local development is the above average trending component in container images, which means there's an essential part of container best practice which isn't being adhered to by the vast majority of people shipping containers in production, which means they are shipping their dev tools into a production environment. So that's the first thing that leapt off this chart at me. The second thing is base OS. Just observe how small those numbers are by comparison. And later on, I think there's another graph where I can dive into a little bit why these numbers in that category are very different from all of the others.
Yes, they seem to that category seems to be an outlier, behaving very differently. But it's like I'm glad that we created these containers because as opposed to looking these individual differences, now we can compare and contrast, which is really helpful. So and here we look into, as I said, not just packages but permissions and libraries and licenses, and we see in these generic, like general purpose ones, our hypotheses being validated, but there are some other surprising results, as I said, around all these like high numbers. And if you are shipping these into production, there's just a lot you need to know for even the more innocent, more specialized environments.
Yeah, and
Let's have.
that's an important thing to bear in mind, is that some of these are very niche, focused, targeted deployment tools.
True, true. Let's talk about the next finding, which is about the attack surface in vulnerabilities, which gets both of us excited and
Hmm.
very surprised in this specific case. And for that one, maybe um, let's look at that bubble chart that shows the sizes of vulnerabilities in different categories, which I believe is page 9. Exactly. So this beautiful chart with so many
I'm going
different.
to zoom in to just a couple of areas as you're talking, so people can sort of see some of the information that's revealed behind this. You do
Yeah.
your thing, and I will scan around this
Thank you.
landscape.
Thank you for that. So basically, what this is about is we take these different categories and we look into the sheer number of vulnerabilities in these images in these categories to see them side by side. So that's why we use the bubble chart, the circular packing view here, so that we can see what's going on and if some of our hypotheses are validated. But I would like to say this very clearly: like, this attack surface obviously is not just the function of the count of vulnerabilities. It's a combination of many things plus the counts, right? So the larger ones that you're seeing here, the legend here is, we should have probably put that and we might edit the report for it, but there are those large ones that have almost 2,000 unique vulnerabilities in them, right? But we are also looking into the criticality of these vulnerabilities, the files in the container with spatial permissions, the total number of packages that would cause a potential zero-day issue, right? All these things. So as expected, when you look into this one big chart, right, the thing that you see is that the number of vulnerabilities in more general purpose categories are higher than others. And this we looked into correlations between vulnerabilities and the other parameters that we are looking at, such as the packages, permissions, licenses, and there is a very meaningful correlation between those things. So this is not as surprising as probably the next thing that we need to be looking at, which is the distribution of severity of these vulnerabilities. That, again, this one just validated our hypothesis that generic purpose ones would have a lot more, but the numbers are still a bit scary. Like, on 2,000 unique vulnerabilities in one container, I think it's just, especially given the pool counts, is a bit terrifying, to
I
be
mean,
honest.
so remembering my first principles of information security, 2,000 things, that's an alarmingly high number, because even if those are all low to medium, you're creating lots of opportunity for that application, that container, to be compromised in different ways and used as a point of ingress into your infrastructure. And there you can island hop to something else and to something else. So, even, large volumes of low risk, exposure can be devastating. And, dare I say, we're streaming on Twitch today, which is ostensibly now public domain for reasons. It could have been a culmination of different security level incursions that led to their public leaking of literally all the things.
Exactly. Martin, there's an asymmetrical war going on, right? What a hacker needs is a single point of penetration into your environment.
Right.
As security admins, they need to be thinking about 360, making sure that the walls are fortified and there's nothing going on. But for the hackers, from their perspective, it only takes one vulnerability, especially if it is unfixed. Like, it is. You can lose sleep over some of these numbers.
Right.
But again, at least from a hypothesis versus validation standpoint, we were expecting to see a picture like this. What we probably didn't foresee coming was the distribution, as I mentioned. And for that, maybe let's go to page number 12. And there is a probability distribution function. Maybe go down a little bit to first see that, because the one above is looking into the category, per category distribution. But this is a general, what is the distribution, the severity of these vulnerabilities across the board type of visual. So I'll just give a second there for the audience to take a look at that. But what I saw when I saw this, okay, was that the distribution of severity of these vulnerabilities, about 20% of everything belongs to a high critical or unknown severity category.
Yeah.
So the expectation is usually about, like, you get most of your vulnerabilities in the negligible, low, maybe even median, the medium severity ones. So that makes up 95 to 99% of everything. And then you have 1% of the high, really critical things that you need to fix. But on average, we are talking about 20% in total being of high critical unknown category. That I was blown away, but I wasn't expecting this at all.
Yeah, it's very surprising to me. And actually, if we just go, what page were we on before? It doesn't matter. The base operating system was a very small grouping, and also the size of their bubbles was also very small. And the thing that I've taken away from this is the extraordinary effort that the likes of Red Hat and Canonical go to ensure the security profile of their base container images, often patching high and severe vulnerabilities within 24 hours of disclosure. If you're paying for that kind of support from those organizations, this chart points out it's all for naught, because if you're piling the other stuff on top, it's fair to assume that communities that maintain language ecosystems and frameworks and what have you don't have the same kind of resources and security teams to back those initiatives, to ensure that day by day, hour by hour, they're producing a secure product. And this is remarkable to me. That this outcome is remarkable to me, because I think there is a lot of C-level executives that think they're doing the right thing, that think their teams are doing the right thing, and I'm sure their teams even think they're doing the right thing. But unless you do this analysis of your landscape of components that make up the infrastructure that you build on and deploy into production, you really don't know. And this is just a continuation of a discussion we had with Brendan from GitLab about supply chain vulnerabilities, and like how this can, really upset your whole information security outlook.
Exactly, and there's more to this. If you scroll up a little bit, then we can look into the per category distributions, which makes things even a bit more interesting. I'll say. So here in this figure, you're seeing the distribution across categories, and it is the color coded by like, you focus on the red, the hues of red, the high critical unknown ones per category. So you can see here in base OS how, as we expected, potentially like about 1% of everything is in this like red category, and everything else is negligible, low, medium, right? But then what we are seeing is that some of the small special purpose categories, such as build tools, DevOps, local development, they have the largest percentages of high critical unknown vulnerabilities. which may be a blind spot, right? You might think that these small functional container images are benign, but they may contain huge vulnerabilities, especially in terms of severity levels,
Yep.
despite their small size and relatively low package count. So that means that that thing that you didn't think would be an issue might be a very important issue for your CI/CD workflow.
Right. So in the chat, Andy Hazen is making the point that he says this goes back to the debate that he has when building containers. Should I use base OS plus install packages from their package archive and ensure they're respun often, or should I use the purpose-built containers from, those language or framework ecosystems like Nginx instead? And it's a valid point. I think it requires some due diligence to fully understand what's right for not just at a whole for your organization, but for that particular application or that container ecosystem. And again, this particular graph outlines the point I was making earlier. There are two things that really leap off this for me. The first is base OS. That's the work that the Linux vendors are doing to make sure they are delivering regularly secure base operating system images to the container ecosystem for people to build upon. Just as Andy says, take a base OS, add the software stack on top, do it yourself. Versus, look at that we've labeled this local development. We've called it local development, but these are for the top 100 containers in production. Look at all of that development tooling that's in production that is horribly vulnerable because it's a bit brittle and fragile and people don't want to change it often. So they're constantly shipping into production, not particularly up-to-date components. And there was one other in there. I think it's the infrastructure piece as well. It's just remarkable. And so, when we talk about container optimization and minification, we talked about size earlier. Yes, that helps with velocity and momentum, but that's not the only story here. By optimizing out of your containers those development tools, then you're also reducing your attack surface and exposure. So, it's more than just a vanity metric.
Yeah, I totally agree. Well, Martin, we've been talking about the report for almost an hour right now.
I knew we would be able to dig into this for some time.
Yes. Like, for me, the main conclusion is like it is the beginning of a journey that we are about to embark upon. This is a new baseline for us as we expand our set and do more. So right now, I think it's a good fair view of the starting point of like most of the development at scale that's happening out there, because we picked hand curated some of the most popular images, but we don't know what's going on down the funnel. So I would like to analyze more, what's going on in there and understand more. And then I would like to start using the data that we create on our own platform. So seeing the X-ray reports of the containers that are being used and understanding what's going on under the hood for those things. So there's a lot to do in expanding the set and going in depth to specific images and understanding what's going on in time. So I'm glad that we had this MVP, if you will, the first report of its kind, and hopefully it's going to start a tradition, a thought leadership piece every few months, and a big piece maybe every year, so that we can see what's going on in the industry.
Yeah, and there is hot debate happening right now in the chat. So I can see that, Yannick is asking the question: isn't the raison d'etre of containers to be identical from the developer machine to production to avoid the "it works on my machine" syndrome? And Big Pod kind of correctly points out, well, yes and no, and that's correct. You do want that, agility and flexibility of developers to be able to iterate quickly and have all of that familiar and comfortable tooling available in their containers. But you don't want to ship that into production. Now, that can be an ordeal. Maybe you start going down the build packs route in order to create your containers in a different way for production versus development, or you use multi-layer builds to again address that production versus development, or, and here comes the shameless plug, you use something like Docker Slim, which simply strips out that convenient development tooling from your containers, so that you can just take your development environment and put it into production, and it is just your production environment without all of the risk and technical debt that's associated with the dev environment that usually sits alongside it. So hopefully that answers those questions. Don't leave your stuff.
You're
Yeah, so
actually
the mentor
working
says, the
on
conclusion is don't leave your stuff in production. Don't leave unnecessary stuff in production, and find automation to strip it out.
We're actually working on a new scoring mechanism, not to reveal a lot before it's like mature
You're
enough.
totally
But
revealing it though right now. You're saying the words.
I guess it's fair to talk about it without
Absolutely.
much detail. So we are looking into these different, and we mentioned it in the not in too much detail, but even in the report itself, that we are talking about these concepts of production readiness and developer friendliness. And the ones that we were looking at, the generic purpose ones, is like, not that these are truly orthogonal categories, but there are most of the images that we are looking into, you can categorize them in a scale for being production ready and for being developer friendly. And the ones that are developer friendly have way too many things in them. That makes it easier and fun, as I said, for the developers. But they don't have a place in the production environment because of all the safety issues, all the correlations that we are seeing between the vulnerabilities and their severity counts, and the complexity, these unused packages, licenses that are being used. So we will start scoring these images with an algorithm, which will be probably improved along the way. But we are looking at these two categories very closely to
Right.
to understand and categorize, classify images going forward.
And I think that's an obvious next step for the container ecosystem, because as you and I have discussed, we've both worked in information security in the past, and I was involved in the very early days of establishing the CVSS standard, which is a way of objectively measuring the severity of a vulnerability in order to right size your risk response to that vulnerability over the landscape of the systems that you operate. And I feel like that's missing. Like, that was a solution to the problems we had 15 years ago, but we don't have a similar mechanism of scoring, assessing, and identifying where we need to invest our attention and concern in this container landscape, because nobody's done this kind of research before.
Martin, 8.2 million images in Docker Hub alone, and that's half of world containers, right? It's just the complexity, finding the right place to start. It's big, and yeah, I think these types of studies algorithms and expertise can help developers start at the right place with the right, spending the right resources into that flow, so that down the road they don't have the headache, the
Right.
complex challenges that the wrong starting point causes. So yeah.
Well, Ayse, this has been a fabulous discussion. I've obviously had the benefit of being able to see this report as it was being developed. Nevertheless, it is always eye-opening when I return to it. Hopefully, you all who followed along with us have found it enlightening as well. If you're watching this after the fact on our YouTube channel or wherever, and you've got questions, then that's the URL above my head. Join us where we are in our discourse and Discord communities. Ask your questions. We will be more than happy to answer those. And if you've got ideas and insight into how we could improve, this analysis into the future, then we're all ears. We would love to hear from you as well. So yeah, get in touch. We're perfectly approachable. We're friendly people.
Oh, totally, totally. This was so much fun to do, and we will be expanding the analysis. But I can't wait to hear from people um, working with these containers, being an expert in specific categories, coming in and looking into what's going on and giving us the insights that they gather with that insider information, if you will. So
Right.
look forward to hearing more feedback on this.
Yes, we absolutely do. So thank you all very much for joining us. The assets, the full report is in our Discord channel. You'll find the links above. And pore over it, pick it apart, and we look forward to your feedback and commentary. And we'll learn to improve on that in the future. So thank you very much, Ayse, for one, taking this on and producing the report in the first instance. But thank you for joining me here today to share that with everyone. And I look forward to seeing how this evolves over time.
Same here. Thank you. Thank you for having me, Martin. Looking forward to hearing more from the audience and other people who get to read the report.
Thanks very much, everyone. We'll be back again tomorrow at the same time, and we'll be doing an AMA about everything you wanted to know or didn't want to know about Slim.AI and Docker Slim. So speak to you then. Bye for now.